Welcome back. Now in this video we are going to discuss the light sources that is usually available for us in minimal access surgery. And in light sources that is available, let me, okay. Before discussing the light sources, just the same diagram what we just saw in the previous video. This is the area of dissection, means the operating site inside, that this area is present inside the patient. Now this is the tip of the laparoscope that is there inside any cavity, thoracic cavity or abdominal cavity and so on. This portion we have already discussed, the telescope and light cable, the previous two videos. Now this video is basically focusing on this light source, right? So in this video we are going to discuss the light source, means light is being produced here and this light is being transmitted through this light cable, then telescope, and now we can see the target organ in particular surgery, right? Now this light source we are discussing in this presentation. So basically, what is the use of any light source? So light sources, basically they help us in producing images by giving or providing us with bright light with even illumination, right? So as you all know, we can only see when there is light surrounding any object, and that light is being reflected back by that particular object, and our retina receives that reflected light in the form of images that is usually formed over the retina, and then our brain interpret it, the occipital area, the visual cortex, and finally we can analyze, okay, this object is this particular thing. So in the similar manner, this the whole amazing concept in minimal access surgery, it takes the help of light sources for producing light. Broadly speaking, these light sources are of three types: the halogen, the xenon, the second one, and nowadays another one is available, that is LED. Halogen light source, you already know this halogen group is, if you can remember the periodic table, the 17th column, the second last column from the right side, the various halogens, the fluorine, chlorine, and all these things. The halogen light source is this one, followed by the xenon, the inert gases group, the xenon, and finally the LED, light emitting diode. Out of these three, the halogen is very economical, available with 250 watts instrument, and this xenon is costly as compared to halogen. Halogen is somewhat giving us yellow light with yellow tinge. And xenon is costly. It is available with 175 watts and 300 watts. So this 300 watts xenon is considered as a standard light source for laparoscopic surgery. But yes, if LED, light emitting diode light source is available, better. Just to understand What are these three different types of light sources? What are the concept that is important for us to know while going through the various light sources? Just understand this point that the sun, it is, this flux is for luminous flux. It is one of the character of any light, and sun is almost giving us 35,000 lux luminous flux, or let's say illumination or brightness, right? When compared to sun, the xenon light source is in the range of 2500 to 3200 lux. I'm giving this data just to give you an idea to compare the xenon light source with the sun light. Okay. After all, we already all of us know that the idea of the light, natural light source, the most important source is sun. So 35,000 lux, whereas xenon 2,500 to 3,200. Almost the sun luminous flux is around almost more than 11-12 times, right? There's a light produced by the xenon light source. Although xenon light source, this is considered a somewhat cold light source, but remember all the three types, the halogen, the xenon, or even LED, light emitting diode, all these three light sources, they produce heat at the tip. They produce considerable heat at the tip. So what is the take home message? Tip of light cable or laparoscope, they should not be allowed to touch the drapes or any internal organs of the patient. So don't touch the tip of the laparoscope over any organ while doing any operative procedure. In minimal access surgery, don't touch the tip of laparoscope with the liver, with the small bowel, or anywhere else inside the abdominal cavity. Don't touch it, right? Just to give you a figure, an idea, the life of xenon bulbs, it is approximately 500 hours. The operating time, the xenon bulbs life span is around 500 hours. And nowadays, the light sources that is available, the light source that is available with us, it gives an indication while operating any light source. It tells us what is the remaining life of the bulb that is being used, what is the remaining life, so that we can easily replace it beforehand, right? Nowadays, variation in the intensity of light is possible. We can change the intensity of light while any operating procedure by the control. The automatic iris and even manual control mechanism is present in all the light sources that is available nowadays to change the intensity of light. Another important advantage of using the present day light sources, the availability of flash generators. These flash generators, they allow for color photography. We can take the pictures while operating whenever we want, when it is connected to a compatible camera, right? So this facility is also available. The present day light sources, we can take the pictures by manually controlling it. The third type of light source, the halogen, nowadays we are not using it. It should not be used. Either xenon light source or LED light source, a better choice. Halogen light source, previously it was very commonly used when LED is not available, was not available, and this xenon light source was not easily available. Then halogen light source, yes, an economical option was there. But my recommendation is just go for either xenon light source or LED light source nowadays, right? So this LED light source, just try to understand the concept here. LED, light emitting diode. this LED light is basically a light derived from a semiconductor. It's a semiconductor light source and it emits light when current flows through it. Then how this current flows through any semiconductor and how it produces light? To know this, these lines are important. In any semiconductor, there are electrons, and the electrons are just jumping from one place to another place, and the place where the electron is leaving, that forms an electron holes. Now, this electron holes is considered to be carrying positive charge. Why? Because now electron carrying negative charge is not there. So this electron holes is basically a sort of quasi-particle different from a positron. Positron is what? Antiparticle of electron. All of you know. This is different from, this electron holes are different from positron. Right? So whenever electrons in the semiconductor recombine with the electron holes, they release a lot of energy in the form of photons. And photons you already know, related to light generation. Right? So LED light source, although it produces less heat, but it can still cause burn injury. So again, the same precaution as we have discussed in the xenon light source, we must take the same precaution in LED also. The light source should be put at a standby mode when we are not using it. These are the precautions we must take while using these type of light sources. And tip of the fiber optic cable or illuminated laparoscope should be put away from the skin and should be put away from the internal organs also, right? Remember, the light generation process always causes heat transmission from a source to the tip of the scope, and direct contact with the small bowel may cause functional as well as cytologic injury, right? The cells of the bowel, at that time, whenever you are touching the scope over a small bowel, you may not notice the injury. But yes, after 3 days or 5 days, patient may present to us with features of perforation peritonitis. So please avoid touching the tip of the scope while operating any patient. Don't touch the operating this tip of the laparoscope with any organ. Just whenever the image is blurred, just take out the laparoscope outside, just clean the tip of the laparoscope with hot water, right? And just clean the lens instead of touching the or cleaning the lens inside the patient's abdomen with some other internal organs, right? Then fiber optic light cables and some other endoscopic devices, remember they always have the potential to cause thermal injury and sometimes even drape ignition. The drapes may catch fire while operating it. So please be careful, especially this is true for the surgeries which require longer time, longer duration. The thermal injury may occur without visible damage to the drapes, means drapes are fine. But even the area that is lying under the drapes, the area of the patient, that may sustain thermal injury if you're touching the tip of laparoscope or tip of the light cable over that particular area. So we must remain vigilant regarding the risk associated with these devices, and we must take precautions to prevent patient injury. The temperature measurement at the tip of the scope, usually it varies from 60 degree to 100 degrees centigrade, and direct contact of the tip of the fiber optic cable, it usually causes total carbonization in the wall of the small bowel. So again the same message, The direct contact of scopes with the intra-abdominal organs not recommended. Whatever light source you are using, don't touch the tip of laparoscope with any organ. Cold light. What is a cold light? This cold light concept nowadays is very important. Cold light doesn't mean that that particular light is cold. No. It means that the proportion of blue, green and red are approximately equal. And these lights, they have been produced by a source around 7000 Kelvin degree color temperature. So light is having two things. The two important characteristics of any light, that is brightness, that we have discussed the lux unit, and the color temperature. Here the cold light is being produced at around 7000 Kelvin degrees, having blue, green and red in equal proportion, right? Domestic light, what we are using in our homes, it has slightly an increased proportion of red. That's why it is warm and is produced by a source around 3000 Kelvin degrees. Whereas in LED, it is 7000 Kelvin degrees, right? In homes, 3000 Kelvin degrees. Can you see here some relation between coldness and warmness of light with this color temperature? Here you can see higher the Kelvin, the color temperature in Kelvin, colder is the light, right? Or lower the Kelvin color temperature, warmer is the light. So one thing is clear, that cold light does not mean that its temperature is lower. Even with the cold light, if you will touch the bulb or tip of the light cable or telescope, you will have a burn. Definitely you will have a burn. So cold light doesn't mean lower temperature. So all laparoscopic light sources at present that is available with us, they produce heat and they can cause burning at full power whenever that is not in the standby mode and we are not using it, and there is at that time there is higher risk of touching the tip, right? So always be careful regarding this. Another important functional aspect I would like to discuss here, the fogging of the lens. That fogging occurs when the warmer, high humid intracavity CO2 carbon dioxide we are using to create pneumoperitoneum, whenever it contacts a colder laparoscope, colder means colder as compared to the temperature of the CO2. Whenever it touches it, there is fogging. And for this, to prevent this, the humidification and warming devices are available. And these devices are usually connected in series with the insufflation device, and it reduces fogging. Few disadvantages of using LED light source. The lifelong exposure of the retina and lens. That is exposure from what? Exposure from blue peaks that is usually there in LEDs. It can increase the risk of cataract and age-related macular degeneration. So it is not advisable to see or look directly through the right light cable or through the tip of the laparoscope. Why? Somebody is going to see the tip of the laparoscope just for fun. So don't look directly at the tip of the laparoscope or at the distal end of any light cable if that is functional at that time, if light source is on. Light emitted by LEDs can cause retinal changes also. So if there is high exposure for even a short period of time, be assured that this is going to damage your retina. So the take-home message from these two lines, whenever you are in the operating theater, don't look towards the OT light as well as these light cables or the laparoscope or telescope, the light coming from the telescopes. Finally, a few important points regarding the LED light source produced by the LED bulbs. Between 5000 6500 Kelvin color temperature, the light get close to the natural colors. This is one of the important MCQs you may have. This is the temperature at which the light seems to be in just similar to the natural light, the natural color. And in this range, the details will look sharp, very clear details you will get. And at this daylight, another advantage is at this daylight color temperature, the eyes won't get tired and we can work efficiently. And what is that color temperature? 5000 to 6500 Kelvin color temperature. Two characteristics of any light is that the brightness measured in lumens, the unit, and the color temperature measured in Kelvin. And this is a take-home message: the higher the color temperature, the cooler light gets, and lower the color temperature, the warmer light gets more warmer. For example, 4000 Kelvin is a cooler light as compared to what? Cooler white color as compared to the light at 2700 Kelvin and 3000 Kelvin. And that's why this light with this color temperature is used in the lamp that has been used in various offices, the waiting areas, and most other commercial applications, right? Whereas the 6500 Kelvin is a very cool white light and it is used to simulate almost daylight, and that's why it is also said that this type of light is going to increase the productivity when used in a work environment, right? 6500 Kelvin, very cool white light. And the light at 4000 Kelvin is warmer as compared to this 6500 Kelvin color temperature. So this is a take-home message. You can see the arrow, this one. As the color temperature in Kelvin increases, coolness of light increases. It is directly proportional to the coolness of light. If it decreases the color temperature in Kelvin, the coolness of light will also decrease, means it will get warmer, right? Just to give you an idea, if the color temperature is 6000 to 6500 Kelvin, it is almost similar to the daylight white. It is known as the daylight white, and then at 4000 Kelvin, it is cool white. Then at 3500 standard white, and at 3000 Kelvin and lower than that becomes warm white, right? So that is all in this video as far as the light sources are concerned. And just to summarize it, three types: halogen, xenon, LED. Nowadays, xenon and LED light sources are commonly used. So thank you very much. In next video, we'll discuss the camera head, the coupler and CCD concept. Thank you.